Unfortunately, the demo program we're using will not capture the model when it's running in graphics mode, so we'll simply have to describe it. Here we see a snapshot image of the model as it is running. In this area, you see the production profiles. Water shown in blue, gas in red, oil in green, and pressure shown in yellow. Of course, if the model were actually running, these profiles would be continuing to grow as we're talking. In this area, you see the recovery factors, which would be changing as the model progressed. If we had injection in this study, we would see the injection profiles in this area. And across the bottom, we see a one-line summary describing what the model is doing as the model progresses in time. These would be scrolling up the screen. Notice for this run, the well was able to maintain the target production rate of 3,000 barrels a day for a short period of time before going on pressure constraint. If it were important to maintain a steady production stream, you would probably want to try a lower target rate so that the well could maintain the constant rate for a longer period of time. While we cannot view the model running in graphics mode, we can view the model running in text mode. Notice that for a single well model with only 600 grid cells like this one, running on a Pentium 300, a 5-year run will take only about 30 seconds. How large of a model can you run? That depends on two things: the size of your computer and your patience. Everything in Merlin is dynamically dimensioned. That means Merlin uses exactly the amount of resources required by the model you describe. I have run an 18,000 grid cell model with 55 horizontal wells on a 486-66. Of course, it took about 3 hours per run, but that's really not too bad. On a Pentium 300 like this one, it would probably take about 15 minutes. On this PC, I would not hesitate to run a 50 or 60,000 grid cell model.